Howdy! In this video, I'm going to talk about MMET 370 lab number 8, which is a Brayton cycle which we use in gas turbine. Brayton cycle is used to explain the working of a gas turbine, which consists of 4 different processes to complete a whole cycle. From 1 to 2, we have isentropic compression. From 2 to 3, we have isobaric heat addition, that means a constant pressure heat addition. From 3 to 4, we have a isentropic expansion. And last, from 4 to 1, we have a isobaric heat rejection. As you can see on the left side of the image, this cycle consists of 3 main components. Number 1, compressor. Number 2, a combustion chamber where the combustion takes place. And the lastly, where the power comes out or through which the power is harnessed, is a turbine. We have a very good experimental setup to demonstrate this working of a Brayton cycle, which consists of all 3 components which I described in the previous slide. As you can see in this slide, this is a cutout view of the setup we have in the lab, and it consists and it's been harnessed with all the required sensor, including temperature and pressure sensor, so we can monitor the data and later we can use the values harnessed and acquired through that sensor for further analysis. This is a screenshot view of the software we have to acquire all the required data, and we can see the real-time data during the experiment. Apart from that, we can also log the data for the experimental runtime, and then later we can download it and we can supply that to the students for further data analysis. So this kind of way, it's been very helpful to acquire the data at very high frequency rate, and it's been used for further data analysis for report submission. The Excel file generated by the software consists of all these parameters, where P1 to P4 are gauge pressure, where P1 is a gauge pressure at the compressor inlet, P2 at compressor outlet, P3 at turbine inlet, and P4 at turbine outlet. In the same fashion, we also have temperature from T1 to T4. The only catch is there is a small change in the order, where T3 is a temperature at turbine outlet and T4 is a temperature at turbine inlet. So please make sure you inform the student beforehand so they don't make mistake during the data analysis. Now in the next part of the video, I will demonstrate the physical unit and I will explain how to run the experiment in proper procedure. Howdy, again I am Vijay here, and behind the camera David is helping me. And today, as you can see over here, is our experimental setup for gas turbine through which we can demonstrate the Brayton cycle. Okay, so today I'm going to demonstrate how to start the experiment in a proper way. So let me briefly discuss each component and then I will start discussing in further detail. So over here, this is my inlet where the air will come in, and as you can see over in this, the middle portion, which consists of my radial compressor, then a combustion chamber, and at the end there is also a small turbine inside, which is not visible through this structure, but it's inside. But at the end, this is my exhaust side, and as you can see, this is my nozzle through which my exhaust gas will come out. So please make sure during the experiment no one is standing on this direction at certain distance. Okay, also this experiment is not meant to run indoor. You need to use an outdoor situation where you can run in a proper way, and also just make sure you have a proper parameter around the setup so no one come close. Okay, alright, so that's all on this what we are looking at. So firstly, during the start of the experiment, you need to make sure that there has to be a supply of compressed line. So in this experiment, we used to conduct near a welding lab, so there is the compressed air supply coming out from there. So you must use that compressed air supply over here. So can you come close over here? Can you see that port? So we use that port to supply the compressed air, and that's very important to start the experiment. Otherwise you will not be able to start the engine. Okay, now on this dashboard over here, if you can take a closer look, I need to have a master key to run the experiment, so please make sure you have a master key over here to start the experiment. These are two switches, start and stop. So start to help me to start my engine. Apart from that, stop is obviously it will help me to stop the engine, cut off the engine. On this I can see my oil pressure level. P3 is the pressure at the exit of turbine. My fuel pressure can be seen in this gauge, and also I can see the compressed air supply pressure in this gauge. Over here in this three panel, TIT stands for turbine inlet temperature, EGT stands for exhaust gas temperature, and RPM shows what is the RPM at any given point for the given turbine inside. Okay. Also, we have ports through which we can connect the laptop, so we can access the real-time data and make an Excel file from that. So this is a power supply for this system, but you can take the data out from this. So make sure you have appropriate cable to connect this to the laptop, so you can get your required data during the experiment. Okay, now how to start the experiment? Please make sure everything is properly well set. You have the key. Please make sure you have the supply for the compressed air. So once everything is ready, this is the main lever through which you can control the RPM, and also you can start the experiment. So once key is on, hit a start button, and then you need to wait until RPM reaches to 8000. So please make sure you wait until RPM reaches to 8000. Once it reaches to 8000, try to pull this lever slowly in the upward direction. Okay, so make sure it's in a very slow fashion, and once it reaches to around 25,000 to 30,000 RPM, you can pull it to the uppermost position in a little bit quicker way. So again, I will repeat this because this is a very important step, otherwise you might have a failed start. So again, I will start here, I will wait here to see my RPM reaches to 8000. After that, I move this lever slowly in upward direction, and once it reaches to 25,000 or 30,000 RPM, I will finish this movement in a much quicker way and push it to the topmost position, and then I will wait, and you will see at the peak RPM or the maximum RPM of this turbine will be in the range of 45,000 to 47,000. So that's the end of a very high RPM, but as the turbine is very small, it will not produce much thrust. So that's the one thing. Apart from this, please make sure you pay attention on the exchange of the temperature. So T3 is a temperature at the exhaust, and T4 is a temperature at the inlet. So please make sure, I already discussed that part in the previous video, so please make sure you inform the student to correct the Excel file generated from the system. So I think that's all from this experiment. Also, please make sure you have a proper fuel level, otherwise it might give a fail start. So we have the inlet at the back side to make sure you have proper fuel. So make sure you fill the fuel tank time to time to maintain a certain level. Also, if you see any leakages inside on this at the fuel entry, please make sure you take proper precaution and contact appropriate person, and don't conduct experiment in such scenarios. Okay, so please be safe, and we'll see you in the next video. Thank you.